All right, I got some vocabulary that we need to look at here. I'm reading a solution that a student gives to a problem here. The question is to figure out what angle x is. And the intent of this problem was to recognize that you have an opposite side and a hypotenuse of 1 and 2, and that this is one of our nice triangles, that if this is 1 and 2, you can use Pythagoras to get the square root of 3 here. This is a 30, 60, 90 triangle. So this is a 30-degree angle here, and then x is 30 degrees, okay? But the suggestion was that you have these things called inverse trig functions. And the very first step that the student gives here is this says, multiply both sides by sine inverse. So he writes this. Okay. Now, as a teacher, I'm always listening to my students' vocabulary. The words that they use tell me something about what they're thinking. I can't read their minds, but I can listen to what comes out of their minds and try to decide what's going on in there. Just the statement, multiply both sides by sine inverse, tells me there's some misunderstanding, right? If you had the equation, the square root of x equals 3, and what you needed to do was solve for x, how do you get rid of the x? Well, square root is a function, and x is on the inside of it. So what I have to do is I have to undo the square root. And I undo square rooting by squaring. So what do? I take the square root of x. Do I multiply it by raising to the 2 power? No, I just plug that into the function of squaring, and I plug this side into the function of squaring. Whoops, I squared both sides. I didn't multiply by 2, I didn't multiply by square. I plugged both sides into a function to undo the function that was already over here. This is x, this is 9, right? So this right here is suspect. I have no idea what's going on right there. So what I want to do is I want to take this and say, I'm trying to solve for x, recognizing that the sine is a function. So the sine of x, I got to get the x out. How do I undo that? Well, I don't multiply both sides by sine inverse. I use the sine inverse function and take it to both sides. So notice the difference here. I'm going to say sine inverse of the sine of x equals the sine inverse of 1/2. Now, what's the difference between the way the student had it written and the way I have it written? It looks like what's in parentheses. Now, so the student's writing was there, my work is here. I've got the half in parentheses where they had the sine inverse. I'm making this look like function notation, where you've got sine inverse of an input, sine inverse of an input. Okay, that is parentheses. These parentheses are functional things, function notation. I understand the misunderstanding because our notation looks the same. That if I write 2x, this literally means 2 times x. If I write, that also means 2 times x. However, if I write, that's f of x. It's not multiplication. It means I've got a function whose name is f, and I'm taking x as the input and I'm plugging it in to see what I get as an output. This is not multiplication. It looks just like this, but it's not. These two look very much the same. This is times, this is function notation, right? And that's what I have up here. The sine of x right here, we get lazy. This is really sine of x. That sine is the name of the function, x is the input. Okay. So I have to I have to do this because I know that later I have students look at something like this and they say, oh, well, let's do this problem again. Let's take the sine x equals a half and divide both sides by sine. So I've got x equals to 1/2 divided by sine, and so, well, they know how to divide, so this would end up with 1/2 sine. And then they get confused because they don't know what to do with that. And they think, oh, well, 1 over sine is the cosecant, so they say something like this, 1/2 cosecant. But they still don't have anything being plugged into the cosecant here. It's like, what? The cosecant takes something. You're not multiplying by sine, so you don't solve by, what the heck is this big old question marks here? I don't know what's going on. You don't solve this by dividing by sine. You solve this by taking the sine inverse of both sides, just like you undid the square root with square rooting. You undo the sine with the sine inverse. Okay. This ends up with, at this point, we've got x equals sine inverse of 1/2, and you can use your calculator. If you didn't recognize that you had a nice triangle anyway, you're going to type this into the calculator, and it's going to give you an answer of 30 degrees. Okay. Be careful with this notation. Pay attention. Are you multiplying? Are you doing a function? If you're solving an equation with multiplying, then the thing you want to do is divide. If you're solving an equation with function notation, then what you got to do is the inverse function. Okay. I remember one time as a kid, I don't know, it was like 5th grade or something like that, I had a teacher that said, of always means times. And it bugged me at the time. I mean, we were doing percentage problems. So 47% of 89, well, how do you calculate that? Well, that's 0.47 times 89, which is whatever it is, right? That this was actually of meant times. Good. So within the context of that problem, that type of problem, of always means times. But I just, at the time, I wanted to say something like, what's the name of your dog? That was what I wanted, you know. I wasn't quick enough. I was only in the 5th grade or something like that. Like, but what is the name of your dog? There's an of in that sentence. It does not at all mean times. But it does mean function notation. Name of dog. Dog is the input. You plug the dog in, and there's a function that spits out the dog's name. There could have been another function that spits out the dog's, breed, or the dog's color, or anything. This is name, and so you plug the dog in, and what do you get out? You get something like Fido out, whatever. So of doesn't always mean times. Of sometimes means function notation. In fact, usually I would say it means this function notation. Only in the very specific case of percentage problems does of ever mean times. But still, that of sometimes means times, and that might be another source of confusion. So, anyway, yes, you're taking the sine inverse of both sides, but you're not multiplying both sides by sine inverse. Okay. There we go. Somehow I need to stop the video, and I don't know how to stop the video.